a curious person might ask themselves, what is the connection between calculating the mean of a probability distribution, the expected value in other words, and calculating the mean of a set of numbers like we did in Unit 3? You may be wondering why the formula for the mean, aka the expected value, does not require us to divide by the number of observations, like we would normally do when calculating a mean for a set of numbers. In the next example, we investigate the connection between calculating mean of a set of numbers and calculating the mean of a probability distribution. So the example we're going to go over is the connection between expected value and the mean of a set of numbers. So this example has to do with a community college. At Rushmore Community College, there have been complaints about how long it takes to get food from the college cafeteria. The following table gives the total cafeteria wait times, rounded to the nearest 5 minutes, for 200 randomly selected students. Here is a frequency table showing the data. So it looks like if you want your food to, the number of people that had their food take 5 minutes or less, or closer to 5 minutes than 0 or 10, in other words, there were 30 students like that. Wow. It took closer to 10 minutes for 52 students. It took even closer to 15 minutes for 62 students. It took close to 20 minutes for 40 students, and close to 25 minutes for 16 students. Here is our formula for expected value. So we have it here. We saw this on the previous page. This would probably be something good to write down, maybe just everything you see in this little box here. The mean, it's probably good to write it in words too, just so you, if in case in the future you forget what those stand for. The mean equals the sum, which means to add them together, the sum of the values of x times the probabilities. And this is only for quantitative variables, not for qualitative variables. So to use our formula for calculating the expected value, we need to determine the empirical probabilities. To find the empirical probabilities, find the relative frequencies, which is the number of times each one occurs, and divide each frequency, or the count, by the total number of observations. So for example, to calculate the probability that a student will have to wait 5 minutes to get their food, we divide the number of students in the sample that waited 5 minutes by the total number of students in that sample. So there were 200 students in this sample. So we'll look at here, there were 30 students out of 200 that waited 5 minutes, close to 5 minutes. Here there were 52 students out of 200 that waited closer to 10 minutes, and on, 15 minutes, there were 62 out of 200. For 20 minutes, there were 40 out of 200, and the last one, 25 minutes, there were 16 out of the 200 who had to wait that closer to 25 minutes than any of the smaller values. Okay. Now, for example, to calculate the probability that a student will have to wait 5 minutes, like we said, to get their food, we divide the number of students in there by the total number of students. When we did that above, or we wrote what it looked like. So they've written it in a table. All those divisions that we wrote above, they actually calculated them here to 2 decimal places accuracy. Now we use our formula to find the mean of the probability distribution, aka the expected value, by finding the weighted mean. So we're multiplying all those numbers from that table, which are just, the number of times, or the number of people that had to wait that long, or divided by the number of students total, multiplied by the wait time. So it's, and this is this particular example, wait time multiplied by the probability for each one. And so we're adding all those together, the sum of all those. So here's one, 5 people that had to wait 5 minutes. 5 is the quantitative variable there, multiplied by its probability, 0.15. Waiting 10 minutes, the probability was 0.27, multiply those, and on and on and on. Together we get a total of 14. We expect students to wait about 14 minutes on average in the cafeteria. Okay, now the dive into understanding the connection between this calculation of the expected value and the usual way of connecting mean of a set of numbers. We will calculate the mean using the frequency table instead of the probability distribution. So back to that frequency table, they've written it again here. We have 200 students, we have 30 students with a time of 5 minutes, 52 with a time of 10 minutes, 62 with a time of 15 minutes, and so on. To find the mean, we have to add. Okay. So we have 35s, and I don't mean the number 35, 35, I mean there were 30 of the 5s, there were 52 10s, there were 62 15s, 40 20s, 16 25s. and then we divide them by 200. So we see it here in this calculation here. 35s, multiply them. 52 10s, multiply those. 62 15s, 40 20s, 16 25s. We divide by the total number of students, 200, and we got 14. So notice one of the rules of algebra, or arithmetic I guess, really is if you have a fraction with one denominator like this, you can think of this as a fraction with one denominator and multiple terms in the numerator. There's 1, 2, 3, 4, 5 terms in the numerator. You're able to split a fraction like that. So imagine if it was just very general, A, B, C, D, E. I don't really know what these are, but whatever. There's something over something, F. You can always split that into the first term divided by that denominator, the second term. They can each you can give them each their own denominator, I guess, is the way of thinking of it. And that's what they've done here. This is equivalent to this. We're almost there. The last thing to do is rewrite each of these fractions like this. So just kind of splitting them off. So let's see. So let's focusing on, say, the first numerator, for example. I'm just trying to make this look more like the first calculation we did. I can kind of split off the 5, make it multiply in the front, and make the fraction just 30 out of 200. And the same thing here. I'm going to kind of pull the 10 out to the front, making it multiply by 52 out of 200, and on and so forth. Now that looks like the same calculation we did with the probability distributions. This fraction becomes this decimal, this fraction becomes this decimal as we calculate them, and on and on. So really, they're really the same calculation no matter how you calculate the mean. If you use probability distributions or you use the actual table of frequencies, but you end up getting the same values. Do you recognize this equation? Yeah, this is the same calculation we did earlier.